Hi friends, so we're going to talk about finding the area between two curves, and so before I explain how to do that, I want to just go into the intuition to make sure this makes sense. So just what does a definite integral represent? So I've got this definite integral, so this is a definite integral of 2x from 1 to 3. So this is actually referring to the graph of 2x, and what a definite integral does is it finds the area under the curve, so in this case from 1 to 3. So I would integrate this and I would plug in my limits of integration, and this represents this area right here. So in general, a definite integral then is referring to the area of a curve from the curve to the x-axis. Okay, so to build up then the idea between the area between two curves, so let's say that I've got two functions, f of x and g of x. We'll just keep the limits of integration the same. Let's also say that f of x is greater than g of x. Okay, so for one thing, if I just wanted to integrate both of these functions, so this would be the area that I would be finding for both, right? Okay, so now how would I get to the area between the two curves? Well, to figure this out, let's put both curves on the same graph. And let's just make sure it's clear what we want. So I am looking for the area from here to here, right? So in other words, we want this piece of area. And so knowing what we know about just how definite integrals work, so if I've got my definite integral of f of x, so it's calculating this area, my definite integral for g of x is calculating this area, I think you can now visualize, right? How do I get to this green part here? Well, I could just take this area minus this area, right? And then I would be left with this last part. So we really just want to subtract f of x minus g of x, and then hooray, we've got it. So to figure out the area here, I would just take the top function really minus the bottom function. So that's the intuition behind this. And I want to make it really clear, you really need to graph the curves. It's a really important part of this. I'm serious. Don't fight me on this. You don't want to make the stick figure angry, do you? Okay. So let's take a look at like a basic example here where the graphs don't get too crazy. And I think if you understand the intuition behind this, I think you can do most of this, quite frankly. So first things first, we have got to graph this. So I want you to pause video and graph the situation here. So let's just check your intuition, make sure you've got the basic idea. And I want you to determine what area is enclosed between the two curves. So start with that and then hit play when you're ready. So I've got y equals x squared minus 1, and then I've got y equals 3. So here are my two graphs. So the area that I'm looking for that's enclosed between the two, this is the area that's enclosed. Okay, so the next thing that we need to do is we need to find the points of intersection. So that would be here and here, where these two graphs intersect. So how would you do that? Well, again, I think just to test your intuition, if you feel like you understand this, maybe pause here, give it a try. Okay. So to find the points of intersection, really what I'm going to do is I'm going to set this equal to 3. So I've got x squared minus 1 equals 3. I'll subtract off the 3 to get x squared minus 4 equals 0. And then I can go ahead and factor. So this will be x minus 2, x plus 2 equals 0. So I have x equals 2 and x equals negative 2. So those are my 2 points of intersection. So I'll just go ahead and label those just so I can kind of pay attention to where I'm at on the graph. And so now I can go ahead and set up my integral, understanding that this is the top function, this is the bottom function, and then these x coordinates, that's going to help inform our limits of integration. So to set up the actual integral, so top function minus the bottom function, and then my limits of integration go from the highest to the lowest. So here's everything that we've got. So now we just need to integrate this, and this is just standard integration at this point. So if I've got 3 minus x squared minus 1, I can just go ahead and collect my like terms. This will become 4 minus x squared. So I can integrate this, and I get 4x minus 1/3 x cubed. And then I just plug in my limits of integration. And so you can see all my work here. And when all is said and done, I will get 32 over 3. Now, you're welcome to pause the video and just double check this work against yours. But hopefully, if you integrated, this is the same thing that you got. Okay, cool. So that's the basic idea. And of course, we should probably take a look at something that gets a little harder. So I've got the area now between x equals 2y squared, x equals 0, and y equals 3. All right, so this says x equals 2y squared. So this is like a function now that's in terms of y, right? Normally it would be like the x is squared, but now it's like the y is squared. So we think of this function like in terms of y. And so I just want you to think about how is that going to change the problem. We will explore that as we go through the solution, but I want you just to kind of think about this on your own. Do you have any guesses? All right, so of course, first thing, graph it. So go ahead and pause the video and just give it a try, graphing it, and then hit play when you think you've got it. Okay, now if you are stuck on graphing, so I've got x equals 2y squared. You're like, I have no idea what this looks like. So just think about, what does y equals 2x squared looks like? Okay, well, that would be a parabola opening upwards. So if I just flip my x and my y, it's still going to be a parabola. It's just now opening sideways. And instead of opening around the positive y's, it's going to open around the positive x's. So graphing sometimes can be one of the harder parts of these types of exercises. And you really just kind of got to use your noggin and your intuition to try to do your best to figure out what these graphs look like. I know it can be the most exhausting part, but it's very important. Okay, so that being said, so here's x equals 2y squared, and then let's graph the rest of this. So I've got x equals 0 and y equals 3. So remember, we're trying to find the area that's enclosed. So what area is actually enclosed by these three curves? It's this little section in here. So again, this is why it's so important to know what it is that you're integrating, because otherwise you might have thought, oh, I'm going to integrate something inside the parabola. And we're not. We're getting this little section here. Okay, so let's go ahead and find the points of intersection. Maybe you want to pause and try that. Remember, math is not a spectator sport, and then hit play when you think you've got it. Okay, so 0, 0, and 0, 3, those 2 points are pretty easy. And then for this last point here, so you just want to be careful, because now we're looking at where x equals 2y squared and y equals 3, where those two things intersect. You're not going to set 2y squared equal to 3, right? Because this literally says what y equals. So what that means is that we're just going to plug that y straight in to the y in the other equation. And so if I do that, so I'll get this point here. So if I solve all of this and work it out, I get x equals 18. So this is the point 18 comma 3. Okay. So the next issue is that we can't do a top minus bottom function here. So we're not going to have an integral in terms of x, because this is x equals 2y squared. So since this is in terms of y, we're going to have an integral now that's in terms of y. So if that doesn't make sense, why can't we do it like that? I can see this on the graph. You know, why does it have to be something different? So you just have to also think about, like, there's another level of complexity here. So if I wanted to use this equation but put everything in terms of x, so to do that, I would have to solve this equation for y. So I have this x equals 2y squared. I need it to be in that form of y equals this function. And that's going to get a little bit more complicated with integrating, because if I go through and I try to solve for y, so first I'll divide by 2, and then when I take the square root, so I have plus or minus the square root of x over 2. So this is just getting more complicated to actually integrate, and this is separating. This is going to create two separate integrals. So it just adds another layer of complication. So it's going to be a lot easier, even though it seems kind of weird. It's going to be a lot easier just to keep everything in terms of y. So we're going to integrate with respect to y, and I'm just going to show you how that looks now. Okay. So instead of doing top minus bottom, so that was how we thought of things for x. So this was, for x's, it was the top function minus the bottom function. So it was the more positive function minus the least positive function, I guess. So we just flip that now in the other direction for y. So instead of top minus bottom, we're going to do right minus left. Okay. And so in looking at this function here is the one that's most on the right. This function here, just x equals 0, that's the one that's most on the left. So I can set all of this up. So I've got right function, 2y squared, and then minus 0. So this is actually also something that's pretty easy to integrate versus the function that we had before. It was a little gnarlier to integrate. It's just going to cause more complications. This is actually much simpler for integrating. And the other thing that we need here is this is a definite integral, so then we just need our limits of integration. So remember, when we integrate in terms of x's, we're always going from we're looking at the x coordinates. Well, now, since we've flipped everything in terms of y, we're looking at the y coordinates. So we're looking for what's the highest y coordinate and the lowest y coordinate. So that would be 0 to 3. So those are going to be our limits of integration. Okay. So now, this is what I need to integrate. And nothing special here, right? So if I just integrate, so I get 2/3 y cubed, and then I just plug in 0 and 3. So I just plug that in, and I'll ultimately get 18. So the math actually on this works out pretty nicely, which is another reason why a lot of times you're just going to want to leave things in terms of y. It's going to be an easier integral. Okay, so I have some more examples on this. So if you would like to see more of either type of example, check those out. And I'm going to leave it there. I'll catch you guys in another video.